Active transducer is one which use biasing supply to convert input energy into output energy. This type of transducer is called as passive transducer. Okay, so the principle it uses is energy controlling principle. Hope it is clear to everybody. Yeah, the counterpart of a passive transducer is active transducer. This type of transducer converts input energy into output energy without using any DC supply. So the principle it is using is energy conversion principle, right? And it is using the principle called as energy what? Controlling principle. Is it clear? Can I make the recording off?
Yes, sir.
If you don't present in the class, I will keep the recording off. I'm telling you. Answer to the question which is asked during the session. Okay?
Okay, sir.
Okay. The example of this type of passive transducer is we are going to learn this thing. Under this, thermistor is falling. Under this, strain gauges are falling. Under this, LDRs are falling. And there are so many other transducer which falls under this particular category. Under active transducer, photovoltaic cell. What do you mean by photovoltaic cell? Solar cells. You know solar cells. Have you heard about solar cells?
Yes, sir.
What is the use of solar cells?
It takes photon energy.
It converts photonic energy into electrical energy.
Energy.
Do we need to supply any DC supply to perform this conversion?
No, sir.
Yeah. So photovoltaic cell or solar cells are falling in the category of active transducer. It follows the principle of energy conversion. I think now it is clear to everybody.
Yes, sir.
There is another type of, so there are so many such transducers. Another I am explaining you, piezoelectric crystal. Have you heard about it? Piezo. The meaning of piezo is its input is pressure. Electric means its output is current.
Electrical current.
Yeah. So this is a crystal. This is a crystal to which we apply input pressure and it gives at the output side what? Voltage. Right? Is it clear? This is called as piezoelectric crystal. I think it is clear to everybody.
Yes, sir.
So we understand this type of transducer, that is active and passive transducer. Always remember in the Viva or during the interview, definitely the employer or the HR are going to ask you this type of question. When you give the classification of transducer in terms of active and passive, you must not forget this thing. At least keep one thing in mind. Passive means dependent on DC supply. Active means it is energy conversion principle based transducer. Will you remember this?
Yes, sir.
Yeah. Now I'm moving to next type of transducer. Next, okay, classification of transducer. This is general classification. Okay. If the implementation is on analog field, it is analog transducer. If the implementation is mostly on digital domain, it's digital transducer. Okay, you'll see the points given here for analog and digital transducer. So this transducer convert input quantity into output quantity as a continuous function of time, right? So it means that it reads the information in its actual form. In nature, I am asking this question. In nature, we observe which type of signal? We observe observed in nature mostly continuous signal, right? It is also called as analog signal. I am speaking. So this is which type of signal?
Analog.
Yeah. So in nature, most of the signal are analog in nature. If we are using a transducer which measure continuous signal in its actual form, then it is called as analog transducer. This is one thing from the point of view of measurement. From the point of view of giving output, if it is giving output in the form of analog itself, okay, then we call it to be analog transducer. So 2 points we need to keep in mind. Analog transducer measure analog input and generate what? Analog output, right? It measure analog input and it generate analog output. Is it clear to everybody? Yes, no?
Yes, sir.
Very simple. It measure analog signal in its actual form and it generate output again in the analog form, right? So example of analog transducers are thermistor, strain gauges. We are going to see next strain gauge. So at that time we will discuss what is strain. Now digital transducer. The same points we can use in order to define what is digital transducer. Digital transducer convert, okay, first what we will do is, we try to convert this continuous signal into okay, discrete signal or discontinuous signal, right? We try to convert the continuous signal into discrete signal or discontinuous signal. So, using a device, you will learn about this in later, called as sample and hold circuit. What do you mean by this type of signal? Can you identify this signal? What is this signal means?
Sinusoidal.
हाँ ठीक है, sinusoidal है. Is it continuous or discontinuous?
Discontinuous. Continuous, sir.
Continuous, sir.
Discontinuous. About this,
Discontinuous.
तो अपन इसको discrete बोलेंगे. क्या बोलेंगे?
Discrete.
We will call it to be discrete signal. Before going information to digital transducer, we need to do this operation. Convert continuous signal into discrete signal as first operation. Second operation. This discrete signal is actually applied to a device called as ADC. Have you heard about this thing? ADC.
Analog to digital converter.
Great. So it generates digital output. Digital output. So this is actually input to our digital transducer. Okay, and it takes digital input and generate digital output. Hope it is clear to everybody.
Yes, sir.
Yeah. ये जो दो ऑपरेशन में जो बता रहा हूं ना आपको, इसको क्या बोलेंगे? प्री प्रोसेसिंग बोलेंगे. क्या बोलेंगे?
Pre-processing.
E-processing.
Pre-processing. So digital transducer are actually not accepting pure analog signal. It need the process data, right? So we need to perform some sort of pre-processing operation in order to form the data which we can feed to digital transducer. That is the only problem with digital transducer. Always remember this thing. Is it clear to everybody? Yes, no?
Yes, sir.
Yeah. Otherwise, we can define digital transducer as it take digital input and generate digital output. What is the meaning of digital input? What is the meaning of digital output? You are already aware of. I don't want to give once more the same explanation. Okay, I'm just reading the text which is written over here. The transducer which convert input quantity into electrical output in the form of pulses is called as digital transducer. Its output is digital in nature. So instead of giving definition like this, if you want, you can give like this definition also. It measures digital input and generate digital output. That is also okay. Hope it is clear to everybody.
Yes, sir.
Yeah. Example of digital transducers are rotatory encoder, shaft encoder, etc. And there are so many digital transducers. Later I will explain you. So this, whichever listed, I will try to explain that. Rotatory encoder or shaft encoder are nothing but these transducers are present in our uh, what is the device which is used to measure the speed of our vehicle? The
Speedometer.
conventional definition is speedometer, but there is some actual definition. Speedometer. Okay, anyhow, let us consider it to be speedometer only. Speedometer actually take, okay, the RPM as input, right? RPM of our tire, right?
Yes, sir. Yes, sir.
Yeah, RPM of tire is taken as input. And in return, generate digital pulses, which we interpret as the speed of the vehicle. Detail you will learn in some of the course which discuss about the working of speedometer. Hope it is clear to everybody.
Yes, sir.
Yeah, all classifications are covered now. Inverse transducer and an actual transducer, that is not necessary for you people. If time permit, I will explain you little later. Now I am going to the next part of this unit, which is nothing but resistive transducer, right? Now please take down this thing, resistive transducer. There are two resistive transducers which we will discuss in this course. One is potentiometer, another one strain gauge. These two transducers we will try to cover in this course. And this is very, very important. Its weight is one long answer and one short answer. Right? 10 plus 2, 12 marks. This topic is lengthy, little lengthy. I am starting this topic in today's class itself. Okay? So, first to take potentiometer. Are you ready for that? Yes, no?
Yes, sir.
You see, this is the construction of potentiometer, and this is the circuit diagram of or the equivalent electrical circuit of potentiometer. Potentiometer is actually a device which converts displacement into electrical signal. So the displacement information is tapped in terms of change in resistance. First of all, let me explain you what is the meaning of resistive transducer. It is a device which measures information in the form of delta R. What is delta R? What is delta R?
Change in resistance.
Great. It is a device which measures the information in the form of change in resistance. So let us consider first example of this device, that is nothing but potentiometer. So on your screen the figure is of potentiometer. A figure is the construction figure and B figure is the equivalent electrical signal. So first point about this thing.
Definition for resistive circuit?
It measures information in the form of change in resistance. It measures sensing information in the form of change in resistance, right? ठीक है? This is example 1. This is example 2. Can I proceed?
Yes, sir.
Yeah. Consider potentiometer. Potentiometer. First, we will cover the construction part. Then we will see the principle. Construction. So it actually consisting of A, B, and W. Okay. It consists of a shaft. It consists of conducting strip. It consists of primary winding. Primary winding, right? So here the DC supply is applied. VT. DC supply is applied across the point AB. Then what happens is, so this is actually the resistance to which this shaft is making contact. So this shaft is freely movable. It can push in or it can pull out. So the displacement of this shaft we actually wanted to measure with the help of this particular setup. So if suppose this shaft is moving to the left side, then what happens? You see the output voltage is accordingly getting changed. If suppose this shaft moves towards left, then what happens? The output voltage which we can tap from the conducting strip will become accordingly different. So in order to understand this circuit, the equivalent circuit diagram can be drawn like this. So the primary winding is suppose represented as R1 plus R2 resistance, right? Suppose this is RT, which is nothing but R1 plus R2. And the conducting strip, this point to this point is represented as W2B connection, right? So if this conducting strip is moving up, then what happened? R2 resistance will be more than R1 resistance.
Yes,
If this
yes.
is going down, then R2 resistance will be less than R1 resistance. So like this, the displacement information can be tracked in terms of change in resistance. The formula which we can use as very simple formula, voltage division rule formula, right? You are all aware of it. Voltage division rule. Voltage division rule. Output voltage V0 we can write as R2 into VT divided by R1 plus R2. Is it clear to everybody? So it means that output voltage is directly proportional to R2. In turn, R2 is proportional to displacement. Hope it is clear to everybody. Yes, no?
Yes, sir.
Right, construction. A moving contact is connected to the potentiometer. A moving contact, which in the figure is called as conducting strip. A moving contact is connected to a potentiometer. A potentiometer. Primary winding is actually called as potentiometer. A moving contact is connected to a potentiometer. Next point under construction. This moving contact can be This moving contact can be linear or angular. This moving contact can be linear or angular. Now I have a question. The one which is shown in the figure is linear or angular?
Angular.
This is linear, no? This
Yes,
is
sir.
this
Linear.
This
Linear.
is linear. It is going in this direction. Angular means the shape can be something like this. The shape can be something like this. Okay? Based upon the application, either we will use linear moving contact or circular moving. Okay. Next slide on. Next write about this. Next slide about this. Output voltage. Output voltage. You can write this thing and also copy this. Then followed by you can write that output is directly proportional to R2. R that is directly proportional to displacement. Because you see R2 is directly proportional to the distance between W and B, right? More the distance, more the resistance. Hope it is clear to everybody.
Yes, sir.
So this is called as principle. Principle of operation. After writing this, the output equation, after writing this, you please write down. The output equation is directly proportional to the position of wiper, that is displacement. Okay. Next write on. Next write on. Next write on. Its advantage is its simplicity. Its advantage is its simplicity and linearity. Its advantage is its simplicity and linearity. Can we give these two advantages to this type of transducer?
Sir?
Can we give these two advantages to this type of transducer? Simplicity and linearity?
Yes, sir.
Yeah, it's very simple to construct
Yes, sir.
and it is linear in nature. Its advantage is its simplicity and linearity. Write a possible disadvantage, which we will discuss later. Poor sensitivity. I will explain this later. Poor sensitivity. Poor sensitivity. I am moving further because I need to cover one more long answer question because strain gauge is lengthy. Can I go further?
Yes, sir.
Yeah. Next, write down quickly. Strain gauge. Strain. Have you heard about strain gauge?
No, sir.
Okay, no problem. It is a device which takes stress or can also be called as pressure as input and give strain, which is represented with this representation. What is this representation?
Epsilon.
Epsilon.
Sigma epsilon.
Okay. Can I call it to be epsilon? See, this is sigma, this is epsilon, right? So strain. So strain gauge is a device which takes stress or pressure as input and give strain as output. Is it clear? Yes, no?
Yes, sir.
Yeah. So before proceeding further, let us see some key terms related to this topic. First, stress is defined as force per unit area. Quickly write down with me. Force per unit area. Second term, strain. It is defined as deformation or change in length per unit length. Change in length per unit length. There are actually two types of strain. There are two types of strain. One is in one direction, another is in another direction. So if it is, in order to explain you that thing, I need to draw a small figure. Suppose this is the length of wire under stress. If suppose because of the application of force, the length is changing from L to delta L. So this is called as epsilon in y direction. Epsilon in y direction. Lateral strain. Lateral strain. So we call it a longitudinal strain. Longitudinal strain. So this is actually in x direction. Delta L by L. There is a chance that sometime because of the application of strain, the diameter may get changed. So this is the actual diameter D. And because of the application of strain, it may become shrink and it become D minus delta D or D plus. Let us consider the positive strain only. Otherwise, we will get confused.
Sir, D minus delta we will understand.
Okay, suppose it is becoming D plus delta D, right? So this direction of strain is called as lateral strain. Lateral strain, and it is represented as delta D divided by. Hope it is clear to everybody.
Yes, sir.
Quickly take another definition. Poisson's ratio. Another key term. Poisson's ratio. So it is represented by this letter. Neta, this is. It is defined as lateral strain divided by longitudinal strain with negative sign. Okay. The meaning of Poisson's ratio is it gives relation between two types of strain, lateral and longitudinal strain. The reason for negative sign is we all know that if suppose the length is increasing, then diameter should be decreasing, right? Yes, no.
Yes, sir. Yes, sir.
Yes, sir.
Yeah, if length is decreasing, then diameter is increasing. That's why this is the sign. The sign indicate that both are opposite in nature. EY and EX are opposite in nature. So can I go to next page?
Yes, sir.
One point you please keep in mind, for most of the metal, the range of Poisson's ratio is 0 to 0.4. Range for metallic strain gauge. Okay, now we will do a derivation of, this is a possible question, long answer question, derivation for gauge factor. If I take 10 more minutes, will that be okay for you?
Okay, sir. We are having 10 minutes now. It is 12:15 now.
No. After 1 o'clock, if I continue for 10 more minutes, will that be okay?
Okay, sir. Okay, sir.
Let us consider the derivation of gauge factor. It is a possible long answer question. Okay. The meaning of gauge factor is, please listen here carefully. Our strain gauge input is what?
Stress
What is the,
or pressure.
okay. Strain gauge is taking stress as input and converting that into strain,
Strain as output.
right? So we consider strain as input, and strain quantity is not measurable quantity, correct? Yes, no.
Yes, sir.
Yeah, we are actually using metallic device or semi-metallic device, which convert this applied strain into equivalent resistance, right? So we will consider like this. Actually, I know I told you that the input to strain
Input
gauge
is stress
yeah.
and output is strain.
Yeah, this is okay. This is okay. This is one stage of strain gauge. So I will call it to be stage 1. stage 1, right? Will that be okay?
Okay, sir.
Yeah. Call this to be stage 2. Either this as input or delta D by D as input. Consider this only. We will consider at a time only one factor. Okay. So I am considering only one. Delta L by L. This deformation, suppose we are measuring. And the stage 2 is doing conversion of this delta L by L to delta R by R. Right? Delta R by R. So the meaning of gauge factor is nothing but delta R by R divided by delta L by L. This is called as gauge factor, which is usually called as sensitivity of strain gauge. What do you mean by sensitivity? Change in output by change in input is called as sensitivity. So actually speaking, this is not sensitivity of overall system. This is actually sensitivity of one part of strain gauge. And which part? Stage 2 part. Hope it is clear?
Yes, sir.
Yeah. To move further, for the derivation of G, let us define this term. Right on. We know that the resistance of a conductor is given by, we know that the resistance of conductor is given by rho L by A, rho L by A. This rho is nothing but the resistivity of the material, and this length of the material, and this is area of the material, cross-sectional area of the material. Okay, have you written this thing? The resistance of a conductor is given by this value. Is it okay?
Yes,
Yes,
sir.
sir.
This is general formula of resistivity, right?
Yeah,
sir?
yeah. General formula of resistance of a conductor. Consider circular conductor. Because the shape of a wire is circular in nature, correct? Usually the strain gauge is of circular shape. So can I proceed?
Yes, sir.
Yes,
Yeah.
sir.
Okay. Right now, next point. If a uniform stress is applied, if a uniform stress is applied, then the length of the material, and its resistance gets changed. If a uniform stress is applied, then the length of the material and its resistance gets changed. Right? To get this relation, what we will do is, right? To get this relation, differentiating, partially differentiating, right, like this. To get this relation, partially differentiating equation 1 with respect to stress sigma. To get that relation, partially differentiating equation 1 with respect to sigma, that is stress. Okay, I'm quickly writing. So I am using D only, I'm not using the partial differentiation representation. Whatever you want, you can use, no problem. But this is partial differentiation.
Sir, this 0 by 0.
That should be signal.
Okay. Is it clear?
Yes, sir.
Hope this equation clear to everybody?
Yes, sir. Understood, sir.
Okay. Assume that, okay, I am taking one assumption. I am calling this to be delta R and this to be delta rho and this to be delta L and this to be delta and rewriting this. Is it clear? ठीक है ना? Is it clear to everybody or not?
Yes, sir.
Yeah, because we want delta R by R, so divide this equation by R. Divide on both sides R. So we can write delta R by R is equal to rho by A delta rho. I'm writing actual value of R. What is the value of R? Rho L by A plus L by A delta L divided by rho L by A. Now, how should I write this next part? Next part I will write it on the next page. Rho L by A square into rho L by A into delta A. Okay. Please solve this equation and tell me what is the next part you are getting. Can I go to next page? Have you taken this?
Yes, sir. Next one. So the last equation was delta R by R. Yes, sir. I have written. I am.
Okay, you are telling me.
Yes, sir.
Okay. Delta R by R is equal to
Rho by A.
delta rho by rho plus delta L by L minus delta A by A. Are you getting like this?
Yes, sir.
Everybody getting like this? You see here. This row get cancelled. This A get cancelled. So maybe I made some mistake somewhere. Ah. This is L. This is rho. This is okay. L by A, rho by A. This is okay. Sorry for this. ठीक, अभी बताइए, is it okay or not?
सर ये डिवाइडेड बाई ए भी नहीं आता सर,
ए भी नहीं आता।
ए भी नहीं आता सर, एल बाई ए जो है ना सर, एल बाई ए और रो बाई ए है ना सर, वो नहीं आता सर पार्शियल डिफरेंशिएशन।
अच्छा,
सर डी बाई डी एक्स जो रहता ना सर वैल्यू,
जी जी
एक्स इंटू वाई डिवाइडेड बाई जेड बोल के रहता ना सर, तो फर्स्ट
जी।
उसमें है ना डेरिवेशन ऑफ एक्स एंड वाई का पहले निकालते, फिर उसके बाद जेड से अलग से करते, ए नहीं आता सर।
अभी इधर देखिए आप, we are doing differentiating with respect to, okay, sigma, considering this as a variable, rho as a variable, right?
यस सर, यस सर।
L by A we can write separately.
सर रो एल बाई ए है ना सर, तो
हाँ,
फर्स्ट
तो
ऑफ
रो
ऑल
रो
वी
को
शुड
क्या
हैव,
करेंगे, डेल्टा डेल्टा रो पे डेल्टा सिग्मा करेंगे, उसका डिफरेंशिएशन हो गया।
जी सर।
ओके, so
फर्स्ट
that's
है
why
ना सर, ये दो है ना सर, रो एल बाई ए है ना सर, तो
जी
फर्स्ट
जी।
इन दोनों का डिफरेंशिएट पर रो एल को एक
नहीं नहीं
टर्म
नहीं,
कंसीडर कर लो आप।
तीनों वेरिएबल्स है, ऑल थ्री आर वेरिएबल्स।
यस सर,
रो इज अ
ऑल थ्री
वेरिएबल,
आर variables, but you consider रो एल as one
वन वेरिएबल।
one variable, and then you consider them as separate. अच्छा सर, डी रो एल
हाँ,
बाई डी।
तो वैसा ही करो, मैं वन स्टेप एक्स्ट्रा लगता है उसको।
सर बट,
But
सर मैं आपको,
this is taken from standard textbook. I will show you on net also. There is no doubt about that. It's perfectly correct. You please take it for now. Later I will tell you. Okay? Please take it now. Proceed like this. Take it like this. So this doubt I will clear you. Okay? Please for now take it like this. Is it okay or not?
ओके सर।
Yeah. Delta R by R is equal to delta rho by rho, delta L by L, delta A by A. Convert this area into diameter. So in order to convert this thing, first to write the formula for area. You know that area of circular wire is pi r square. So if you differentiate this thing, delta A will be in terms of d, we can write pi d square by 4. So delta A will be pi by 4 into 2d delta d, right? So delta A by A we can write as pi by 4 2d delta d divided by A is equal to pi r square. So this will become 2 delta d divided by, okay, d square by 4. Then it will become delta A by A will become 2 delta d divided by. Is it okay? Now convert area into diameter. In order to do this thing, first consider area of the workpiece pi r square. In terms of diameter, we can write pi d square by 4. So if you differentiate, it become pi by 4 2 delta d, 2d into delta d. Okay, then we divide by a. It will become like this. Finally, delta a by a will be this one. Substitute this in this above equation. Is it okay? Is it clear to everybody?
Sir, I have got it as like this, sir.
Like this only you are getting?
1 minute, sir, I will show. See, sir, I am getting like this. If I am doing all this value, I am considering one as rho L.
No problem. What is the answer you are getting better?
Rho by L dl by d sigma plus.
No, no, no. You must get like this. You please stop showing the screen. We'll take your case little later. Yeah. Let me to finish off this thing. I'm telling you, I will come to you, right? You please email me your work. We'll check and get back to you. Can I present my screen?
Yes, sir.
Please consider this equation delta R by R is equal to delta rho by rho plus delta L by L minus delta A by A. If you convert area into diameter, delta A by A is coming as 2 times of delta D by D. Substitute this in this equation, we are getting delta R by R is equal to delta rho by rho plus delta L by L minus 2 delta D by D. Is it okay? My screen is visible?
Yes, sir. Yes, sir. Yes, sir. Visible. So, yes.
Okay. Now, in order to substitute in this form, delta R by R divided by delta L by L, what we will do is we divide this equation by delta L by L. But before that, we want Poisson's ratio to be there in this equation. So, substitute Poisson's ratio, we know that it is equal to delta D by D divided by delta L by L. Okay. So, in order to do so, what I am doing over here is taking delta L by L common. So, inside bracket I can write 1 minus 2 delta D by D divided by delta L by L. Is it okay? Can I write like this?
Yes, sir.
Yeah. Then delta rho by rho plus delta L by L into 1 minus. You see, minus of these things will be the theta. So theta will be okay. The negative, this negative and this negative is counteracting, and then we will get 1 plus 2 theta as delta R by R. Is it clear? So in order to get G form, what we need to do is we need to divide this equation by delta L by L. Therefore, delta R by R divided by delta L by L is equal to 1 plus 2 delta rho by rho divided by delta L by. This is the equation I am getting for gauge flow. Is it clear to everybody?
Yes, sir.
So we need to start from here and we need to proceed up to this thing in order to claim the long answer marks. You'll be getting a question like this. Prove that the gauge factor of strain gauge is equal to 1 plus 2 theta plus delta sigma by delta rho by rho divided by delta L by L. So discussion on this we will see in next class. Maybe one of you asking a question on this particular thing, you please email to me. I will discuss your case and get back to you in next class. Okay?
Sir, we two got the same answer only, sir. I showed you that derivation of dr by d r is equals to rho L by A.
No
I
problem.
got the same answer. This same answer only we
No
have
problem.
got.
No problem. You can proceed in this way or you can
Uh,
proceed in that way.
But no, I was just asking that you are writing row and that changing, no, sir. You are
Yeah,
changing row and
actually, you are sitting behind the screen here, so there will be a communication gap. Maybe
right,
that is
right,
the
sir.
reason I may
Right,
not
sir.
be able to actually catch your question, right?
Right, sir. Right.
So that's why
No,
I'm
sir.
telling you.
We both have got the same answers only, sir. I
Yeah,
was
yeah,
just saying that after deriving, I got this value.
no problem, no problem. I got it. Thank you for that. The reason why I'm confident about this thing because this is all made with all principles and it is taken from genuine textbook.
Sir,
So we start.
when I derived, I got right. You directly wrote the answer, no, sir. With respect to sigma stress and that.
Yeah.
So
Maybe
I derived that value and I got
okay,
the
okay.
same value as
Maybe I skip some of these steps, right?
right, sir. Yes, sir.
Okay, I'm just revising. The second stage of gauge factor, sorry, strain gauge is this one. Its input is strain and its output is change in resistance. So we want to get relation between these two, that which is called as gauge factor. And it is also called as sensitivity of strain gauge. To do derivation of this thing, we started from the basic consideration of a conducting wire, whose relation is given by R is equal to rho L by A. So, because we know that when we apply the some amount of stress or pressure on it, then only its dimensions are getting deformed. So, we want in order to get the relation between the applied pressure or the stress in terms of change in resistance, then we need to differentiate this equation partially, okay, with respect to the applied input, which is nothing but stress. So for that, we are differentiating partially this equation with respect to sigma, which is stress. So three parts we are getting as we have three variable. One part is contributing this value delta rho by rho. Second part is contributing delta L by L, and third part is contributing delta A by A. Is it clear to everybody? If you directly write from here after this equation, this also no problem. Nobody will ask you. Is it clear? Arey bolo bhai. Is it clear to
Yes, sir.
everybody?
Yes, sir.
Yeah,
Yes.
we want to actually convert this variable information from area into diameter. So that's why we are doing this work, considering the definition of area, doing partial differentiation, dividing by A. So finally getting delta A by A as 2 delta D by D. Substituting this in this equation, then the relation, the relative change in resistance. So क्या बोलेंगे? What is this term called? बोलिए. What is this term called? Relative change in resistance. क्या बोलेंगे इसको?
Relative change in
Relative
resistance.
change in resistance. Relative change in resistance. So we'll be giving three parts as algebraic sum. One is delta rho by rho, another delta L by L, then another 2 delta D by D minus 5. So, because we want to, in most of the problem, we are actually using the property of Poisson's ratio. That's why we are trying to insert this property into this particular equation. So, in order to do this thing, what I am doing is I am taking delta L by L common and I'm inserting sigma into our equation. So, our equation is becoming the relative change in resistance is becoming delta rho by rho. Okay, plus delta L by L into 1 plus 2 sigma. So we know that gauge factor is given by change in relative resistance divided by change in relative length. क्या बोलेंगे? Change in relative resistance. Sorry, relative change in resistance divided by relative change in length is called as gauge factor. Relative का मतलब समझते हैं? Do you understand the meaning of relative?
Yes, sir.
समझो एक क्लास में लॉन्गेस्ट बच्चा है 7 फीट का. How can we measure our length with respect to him? That is called